The region of Endroy in the south of Madagascar has a semi-arid climate with high rainfall variability and suffers regularly from droughts that affect the region's productive systems. The inhabitants of the Endroy regions, called the Antadroy, live mostly in rural areas and depend on agriculture for their livelihoods. Traditionally, they are cattle herders who grow food crops mainly for their own consumption and sell the production surplus on local markets. But over the last decades, wind and water soil erosion, as well as longer and more frequent droughts, have led to a decline in livestock farming activities, and agricultural yields have decreased, thus threatening food security. Several famine episodes prompt the international community to provide emergency support for vulnerable populations affected by recurrent droughts or by climate change, which have also increased migration out of Endroy and into other regions. However, some innovative solutions exist. Through the integration of food plants that are able to withstand drought while also restoring and maintaining the fertility of cropping plots, the Malagasy NGO CTAS aims at improving the coping capacity of households to overcome drought. CTAS promotes the use of agroecological methods on field, with the objective of creating dense agroecosystems that are both drought-resilient and productive. Those large-scale, complex, multi-level ecological systems are called agroecological blocks. In such blocks, several common agroecological techniques are closely intertwined. For instance, prickly pear cactus is used as a natural fence and is an additional source of animal feed, while pigeon pea hedges are commonly associated with intercropping of maize, sorghum, or millet, with pulses such as cowpea or lima bean that fix nitrogen into the soil and improve its fertility. In addition, hedges protect the topsoil against wind erosion, while vegetative strips of fodder, like bracharia, stop runoffs following precipitations and thus reduce water erosion. The soil is always covered, either by creeping crops, like most of the bean species, or by cover crops, grown specifically to avoid bare soil, like dolichos or the legume mucuna. They add nutrients to the soil and improve its water balance. Less evaporation takes place and more water remains in the soil, enhancing the ability of the system to cope with irregular rainfalls. Soil is put at the center of the whole system because it is the natural resource most easily influenced by good agricultural practices. As a result, harvest is better, with positive effects in terms of food availability and nutrition for the farmers, as well as animal feeding at the farm level. But the question is, how has CTAS managed to foster the implementation of large-scale agroecological blocks with smallholder farmers of Endroy who have a low propensity to invest and less than 2 hectares of land at their disposal? The CTAS strategy was to use a multiplier system to spread knowledge about new plant species introduced by the project, and to start breeding and producing seeds to give farmers access to varieties adapted to the local semi-arid conditions. Above all, CTAS started trials on its own fields to determine which new varieties and agroecological techniques were the most suitable for Endroy. These fields, once grown, were used as farming field schools where farmers of the neighborhood could observe the results. The first farmers who started using agroecological practices on their plots with the support of the CTAS were selected on the basis of their strong leadership potential and good integration into the community. They became the first relay farmers, in charge of promoting the new techniques and varieties by organizing visits and trainings in their fields. After taking part in a training or a visit, each participant would receive the seeds of the varieties presented on field, so that they could test them on their own plot. CTAS staff and relay farmers provided technical assistance for the newbies, who sometimes became new relay farmers themselves. In addition, to overcome the lack of inputs and particularly of seeds, CTAS, together with local farmers, developed participatory breeding processes and selected varieties that are best adapted to Endroy. These varieties were then entered in the Register of Quality Declared Seeds of the Anosi and Endroit regions. Once varieties were registered, CTAS and selected farmers started to produce seeds and to distribute them through a private network of 140 farming input shops located in villages. Thanks to this complex scheme and the strong involvement of local communities, agroecological practices spread from plot to plot until the many small plots became landscape units or agroecological blocks. A virtuous cycle started as the dense and diverse vegetation of the blocks led to the creation of favorable microclimates, strengthening the productive potential of ecosystems and their coping capacity against drought. With a greater natural resources endowment, farmers were now able to achieve better harvests and to diversify their income sources by engaging in activities related to agricultural extension services, such as seed production or shopkeeping, thus improving their resilience against shocks. We hope that the presentation of the CTAS and its agroecological blocks inspired you to do the same. We look forward to your success stories.